Okay. I'm Roger Easton. I'm on the faculty here at the Center for Imaging Science. I've been here just about as long as it has. But it's my distinct pleasure today to welcome Christina Duffy, who's the imaging scientist at the British Library. Christina and I had not met before, but we certainly communicated. We know a lot of people in common. And we've done some projects that are relevant to each other. But the other thing I find really interesting is her original goal was to become a planetary astronomer or something of that ilk. And that was my first goal, arguably 40 years before. But nonetheless, we started out sort of from the same plane, and we've evolved by various paths to doing imaging of historical objects, primarily manuscripts. So rather than me continue to babble, I will turn it over to Christina, because I'm sure you'd rather listen to her.
Thank you very much, and thank you to Roger for inviting me. I'm very excited to be here. So I'm going to tell you all about what I do at the British Library, kind of what the typical collection is, what the typical challenges that we have at the library, and show you kind of a range of results and projects that we worked on. So science at the British Library, we have two scientists that work there full time. So Paul Garside is a material scientist. He works on looking at
That be convenient?
Can people hear me? Testing. Is that louder?
I don't hear a difference.
Don't hear a difference?
Not yet.
Hello? People at the back.
Yes, yeah.
Oh, this one.
Ah, okay.
Have you turned this off? So there you go. Okay. Hopefully everyone can hear me now. Okay, yes, that's good. So we have two scientists at the British Library, one for materials testing and myself for scientific imaging. We're quite separate. I'm also separate from our main imaging services who do the traditional digitization, so looking at the large volumes that come in, they would just generally churn through that material, whereas I'm based in the Conservation Centre, so and I get to work with the conservators and also with the curatorial department as well. So it's really important, this kind of relationship that we have with the curators and the conservators, so that we can get these research projects up and running together. So the typical imaging science things that I have to do, digital microscopy, multispectral imaging, transmissive MSI, reflective transformation imaging, and then image processing of all of these types of images that we do collect, and I'll explain as we go through which bits are which. So firstly, a little bit about the British Library, if you're not familiar. This is the building here. It's in St Pancras, which is pretty much the centre of London. The train station St Pancras is behind it, that spire there with the clock, and this is the main library here. It's supposedly architecturally designed to look like a big ship, if you can make out a liner. And a lot of the windows are circular, so it has that kind of feel of being a ship. This kind of piazza in the front, underneath that is the main storage area of the basement. So it's underneath that particular area where a lot of the collections that are not accessed too often are held. The British Library, we have over 150 million collection items, and unfortunately an additional 30 million are added every year. It is a legal deposit library, which means that we're legally obliged to take in anything that's published in the UK and Ireland. So obviously our collection is getting huge as the years go by. We hold material over 3,000 years old. We have over 310,000 manuscript volumes, over 8 million stamps, 60 million patents, 4 million maps, 260,000 journals, to name but a few of the items that we have. The basement then that I mentioned, it goes down 24.5 metres below, which is roughly the size of an 8-storey building. And assuming the collection stopped growing, which unfortunately it doesn't, if you looked at 5 items every single day, then you would still not have seen the collection after 80 years. And after that you can read the internet if you have that kind of time. So this means that we need to have extra storage. So we have a second location in Boston Spa, which is in the north of the country, up near Leeds. And this building here, this is the National Newspaper Building, which has these robotic cranes which will access the material when it's located and take it down. So it's quite an impressive looking building, but it does mean storage is becoming a massive issue for us. But generally we have a lot of items. Then the treasures of the British Library are some of the items that I would have looked at. So we have a treasures gallery, which is a free gallery when people come into the library itself. And a lot of these manuscripts are on exhibition all the time. So we have Magna Carta, we've done Sutra, the first printed book, Times first edition, Lindisfarne Gospels, Leonardo da Vinci's Notebook, St. Cuthbert's Gospel. We have music manuscripts from the Beatles, we even have sound recordings from Nelson Mandela's Ravona speech and Beowulf Codex Sinaiticus. The list goes on, but basically it's some of the most important material that the world has at the library. And the fundamental purpose of the library, which leads you to my role, is to make intellectual heritage accessible for everyone for research, inspiration and enjoyment. So therefore, if you can read the bottom line, it's imperative that these texts are legible. So, GLAMS, that is Gallery, Library, Archive, Museums. Why do GLAMS need specialist imaging? Fire damage. So these are the kind of things that we come across in the British Library collection. Fire damage is going to render text and illuminations illegible. It will shrink the material. Sometimes the text is skewed. And the imaging is going to help us to penetrate any such layers of dirt, water damage that have occurred over the years. A lot of the material has faded and corroded ink. So these are indistinct areas of text which they've either degraded naturally or purposely have been erased over the years, somebody coming in and scratching things out. And a lot of these examples are in marginalia, so inside the margins, inscriptions on the front, maybe names, seals, and indeed the shelf marks themselves. So sometimes we're just trying to get shelf marks back for cataloguing, it's not just to reveal exciting information. Then there's chemically erased ink, so this leads to discoloration as a consequence. So this is people coming in, wanting to read a passage of text and applying chemicals over it to try and rebalance the original ink formulation, which results in horrible staining of the items, which unfortunately we do have quite a lot of examples of. Then we have palimpsests and underdrawings. Palimpsests are overwritten text where parchment's been scraped away and rewritten new text over. And then underdrawings, a lot of our illuminations, we have practice drawings underneath what you can currently see. So these are very interesting to see what the artist was thinking about before they finalise their imaging. We've also got over 3,000 papyri at the library, and a lot of this is encased in glass housing. So at this point, we've got a dirty papyrus, so we can't actually see through it. So imaging is very useful for that. Mapping watermarks against chain and laid lines. So again, this is really interesting to find out where the paper came from, what workshop it was in, but also comparing those chain and laid lines that are on the page with the watermarks so that you can really pin down where it came from. Undercovering medieval waste. So this is, if you open up a manuscript, that inside cover is called a paste down. And quite often the material they would use to create that was old waste material that they'd have in the workshops, that they just take any bit of parchment that they had, stuff it in there, but quite often it was important material. So we're able to image through that paste down and recover what little bits of paper they used. And then mapping fold marks on single folio items. This is useful if we have a large format item, but it has these fold marks. We can see how it might have been used in the past. Was it a practical item that was carried around as a folded item, or was it held open in prestige as a one single page document? And then also highlighting scratched glosses. So these are glosses that would be notations between lines of text, and scratched is just they're not using ink, they're just using some implement to actually make an indentation on that. And finally, revealing previous cases of conservation work. So this is something that's very important for us to separate. Is it something old that we're looking at, or is it something that a conservator has done 20 years ago? So we're able to see those differences quite clearly with some of the imaging that we do. So multispectral imaging is the most used imaging technique that we would use at the library. And this is a system that we have here. This is the MegaVision system, which is also at U of R. And this system here, it's is based on the electromagnetic spectrum. If you're not familiar with that, it's in the top right hand of the slide here, and this is showing you the entire range of possible different wavelengths that you could have. And it's just showing you here that this visible wavelength is just a tiny little piece of this entire spectrum. And what multispectral imaging does is allows you to go either side of that visible range and allow you to see things that you can't within that. So you're going into the UV on one side, and then you're going into infrared on the other. And then depending on the chemical composition of the item that you are imaging, it's going to react in a different way to the illumination and allow you to capture different information. So this particular setup here that we have at the library, We capture over 14 spectral bands from 365 nanometers in the ultraviolet right through to 1050 in the infrared. And the setup is like so. So we have the two LED light panels are either side. We have our camera in the center, and underneath this is our filter wheel, which I'll explain in another slide. And then we set up the item as parallel to the lens as we can. And then what this does is, every time both lights come on, they will take a picture. So if you have two red lights come on, it takes a picture, two blue lights takes a picture, and so on and so forth. And you can take as many different combinations as you like and take as many different images as you have. So you can also do raking, so just using one light on one side, one on the other. It's really up to you and the time that you have and the data storage that you have for you to decide what kind of sequence that you want to have. The filter wheel that I mentioned gives some of the best shots. What this is this kind of dinner plate type thing here, which in our case has a red, green, blue filter on one wheel, and then has a UV block, UV pass, and an orange filter on the other. And you can again program the sequence to run different color lights with different color filters, and that will again give you different information depending on what your manuscript is composed of. The two types of ultraviolet capture that we do is to do with this filter wheel, so we can get UV fluorescence and also the UV reflected. So UV fluorescence is your source is stimulating fluorescence of the actual material, and it's re-emitting a wavelength into your camera, so it's at a different wavelength from the emitted. And then reflected is again starting with the same UV light source, but ending with the same reflected UV light. So again, depending on your object or how it's housed, it's going to give you different information. So the projects that we do at the British Library are largely to do with the Cotton collection, which is named after this handsome gentleman in the middle, Sir Robert Cotton, with amazing hair. He collected all of the really important collections that we associate with the British Library. So his collection was Lindisfarne Gospels, Magna Carta, Sir Gawain and the Green Knight, Beowulf, list goes on. It was an amazing collection. And actually last year it was just added to the UNESCO Memory of the World UK Register, so it's a really significant collection. Unfortunately, it's also associated with being called the Burnt Cotton Collection. This was because in 1731 there was a huge fire where the manuscripts were being temporarily held at Ashburnham, unfortunately named House in Westminster. Now only 13 entire manuscripts perished completely, but there was significant damage to quite a lot of the collection. And it was basically the conservators at the time, they had to go around, pick up whatever they could find, little bits, fragments, and store it away, hoping that someday in the future we might be able to do something with this material. This is some of the kind of material that it leaves us with. This kind of little box here, we've got drawers and drawers full of these tiny boxes full of little bits of manuscript, which we really can't hand out in the reading rooms to give to people to read. You could just sneeze and lose half of the item, or you could sniff and inhale it. Either way, it's not useful to hand out. And we're actually starting a project next year on this material to kind of figure out how exactly we would want to image it, how would we present it, as obviously it's something wrecked over, so front or back, we don't actually know which way it would be. Do we image them all at once or in bits and then try and fit them together? So next year I'll get to figure that all out. And we also have some items like this guy in the bottom left, which we call the brain, which is just, you can't do anything with it, and that's the way it is now. And then what I've done a lot the last couple of years is material similar to this on the bottom right. These are larger parchment fragments which have been inlaid into binding. So this is parchment which conservators at the time, they collected all of these larger fragments which were semi-legible and unfortunately bound them into paper inlays, but parchment and paper are going to behave differently to changing temperature, relative humidity, which results in the parchment trying to move around in the page but getting trapped, and it ends up giving you this undulated kind of feature, and you can't actually close the bindings down, so it's a really unfortunate situation. So the project that I've been working on is to try and image all of this material that's become completely darkened over time. And this is one of the examples of this. So we had a big exhibition last year on Anglo-Saxon fragments, and most of the material in the bound manuscripts are like this. You just can't read them, they're just completely black. So the idea was we were going to digitize them, but there was no point in just using standard digitization if it was going to be still just a black page that you'd be looking at. So there is this project of fragmentarium, which a few European institutions are taking part in, where other institutions have similar fragments of material, and we're trying to get that stuff online. So what we did was multispectral. That was our contribution to that. And you can see with the multispectral, typically the UV shocks were the most useful in this case. Most of the text, pretty much all the text was recoverable quite easily. So this was done for this entire manuscript here. So it's Cotton Author A1. And all of these images are now on the Fragmentarium website. So this has been really useful to our scholars, especially we've now discovered that a lot of them were not bound correctly in the right order. Some of them are upside down, some of them are associated with different manuscripts that we weren't quite sure where they were, because obviously they just found all this material and put it together as quickly as they could. This one was quite interesting in that before the fire they had actually made a facsimile of it in about 1697. So we actually have this copy of what it should have looked like originally, and then we can compare with our recovered text there on the side. So that's been very exciting. We have so much of this material. I'll probably spend the rest of my life doing burnt stuff, so I will look forward to that. And this was also used in 2015 for our Magna Carta project. So 2015 was 800th anniversary of the sealing of Magna Carta. We have 2 of the original exemplifications at the British Library. There's 4 in total, with the ones in Salisbury and 1 is in Lincoln. And the 4 were reunited for this 800th anniversary. So part of that was to do multispectral imaging, microscopy, any type of analysis on all of the documents that we have at the library associated with Magna Carta, so articles of the barons, papal, any documents that related to or talked about Magna Carta as such. And it was during that reunification event that I gave a talk on the imaging, and I showed one of these slides, and these marginalia notes on the side had never actually been noticed before that came out using multispectral. These are from the 15th century, so it's just quite interesting for the scholars that actually this was still up to the 15th century, quite a used document, that people were still actually allowed to make notes on it, which is certainly something that we would not be doing currently. But unfortunately, the fire, the other exemplification that we had, got a little bit damaged in the fire. This one also has a seal on the bottom which got completely melted, so that was unfortunate. So we did multispectral on this for the exhibition. And again, this is the photo shoot software that comes with the Magna Vision system. And these are just showing you all of the different images for each of the different sequences that are run. And this was using 3 iterations of PCA, which is statistically sorting out the data and finding the principal components of the data, which some of you are familiar with. So obviously we know what the text of this was. That wasn't particularly revelation. We already have the clean copy, but it's very useful to be able to compare the hand and see was it written in the same order, were the sentences the same, did they change, anything like that. This project, I got to go to BBC Breakfast for that, absolutely terrifying. My pupils are so dilated there, serious stress situation, but it was very good for British Library. On other projects that we did, and this is Bodleian Gospels. So this was actually on exhibition last year, some of the results in the Anglo-Saxon exhibition. This was copied in a scriptorium in Brittany, early 9th century. But what's really interesting about this is it was actually used to record 51 grants of manumission, so the names of the freeing of the slaves. And a lot of these names have been lost over the years, so it was very useful to image this and discover that it's actually quite significant text along many of these folios. And those that were freed, they often bear these Cornish names, so it really shows the impact of the monastic community in these names. So that was part of the exhibition. We had several images on that. Another folio from Bodleian Gospels was this showing a frame with 5 roundels, which was unfinished, but using some multispectral results we can see that there were some more details to be shown in this. What's also interesting is that, so if we go up to this one, the central roundel, you can see the kind of 2 legs here, and down the bottom is a figure in the right-hand side. And it depends on what it is that you're looking at. You see the legs are not so obvious in this section, but the figures are clearer. So quite often we have to use a combination of these images and provide scholars with multiple views of the same things. There might be more information in one than the other. Sometimes there isn't just one magic shot. Palimpsests, again, these are something you might be familiar with. So to make something like a complete Bible would have taken about 200 sheepskins, which was absolutely enormous and hugely time consuming and expensive. So because something like this is so expensive to do, quite often the materials were reused. So what they would do is they'd take old manuscripts, they would remove all of the ink that had been put on it, wash it away, create a new blank page. Quite often they might cut it, turn it 90 degrees, and use it again as a brand new piece of paper. This is called palimpsest, and unfortunately quite often the text, which is now the undertext, was more important or significant than the overtext. So multispectral imaging has been very good to enable us to apply colours to the different layers of text and enable scholars to read this undertext. A lot of this is based on work from Roger in the past using Archimedes palimpsest. So this one here, we can see we have assigned different colours to different images which show different amounts of information, and it just makes it clearer to see which layers of text are which. Unfortunately, at the library we have lots of different palimpsests, and we also have double palimpsests. So this is when they use it again, so they rubbed off 2 layers of text and then they had a third written over it. So this again makes it even more difficult. This example here, you can see there's an unsealed hand on the bottom, and then the top shows the cursive hand. So it's quite difficult to completely separate those 3 layers of text and provide a scholar with here are the 3 separate layers of text. So the best way to do it is again to use this pseudo-color technique in trying to apply different colours to the different layers, just allowing them to visually read one layer bigger than the other. So you can see it's a lot easier to visually separate those layers from that. And just zooming in apart from that, you can somewhat see those 3 layers easier. So again, this is a lot of work with the curators, again asking them what it is that they want to see, what kind of problems they have. Do they want to see all of the text together? Do they want different colours on which? So it's really a collaboration and trying to figure out what it is that they'd like to see, and not just doing what I think they'd like to see. Then our papyrus collections. So we have over 3,000 collections, as I said, and again, they look quite dirty like this, quite illegible, but in the infrared for papyrus, which if they're written on with a carbon-based ink, it's quite useful to use infrared on this. And our collections, we have Greek, Latin, and Coptic papyri. And many of ours are housed in glass, so unfortunately, the glass that they use to house these in means it's very easy to give to readers and to hand out, and accessibility-wise, it's very good. But it does make imaging difficult if there's a reflection back into the lens. Also, the glass that they use seems to differ in its UV reflectance, so sometimes you can use a UV shot, sometimes it doesn't work. So it's really trial and error for quite a few of those collections. And what you can see is really much easier to transcribe information using infrared. And the next project that we did, Codex Arundel. So this is a manuscript of Leonardo da Vinci that we have in the Treasures Gallery. And you see his date of birth here, or this is his 500th anniversary of his death was last year. This year, death 1519. So there was big celebrations this year. So the Codex Arundel that we have went on exhibition alongside Codex Leicester, which is the one that Bill Gates owns. He paid $30 million for it. And now Leonardo is known quite significantly for his paintings, but actually he has much more information out there in terms of his ideas in his notebooks. So there's over 16,000 pages of notes that he has, whereas there's only about 20 or so paintings that he's particularly renowned for. So one particular folio that we had on exhibition, our copy is completely disbound, so you can see in this image here, each folio is its separate collection item. This is in the Treasures Gallery. And one of the particular folios that was on exhibition had this stain in the center that was brought to our attention. And we were asked, what is it? Is there something that we can look at, or is it of interest? So we took it up at exhibition, brought it down to the lab, and discovered that there's actually this little figure here in the center. So this is quite exciting for our scholars. Martin Kemp, who's a Da Vinci aficionado, his theory is that this seems to be based on Michelangelo's David. So due to the rivalry between Michelangelo and individually, maybe he wanted to erase it to show that he wasn't interested in his particular style of drawing. So complete speculation, who knows, but it just brings certain interest into why he may have erased this, and certainly more significance into looking at any stains that exist in other manuscripts to see what else we might be missing. Another project that I was involved in is the Sussex Declaration of Independence. So this is housed at the West Sussex Record Office in the UK. And this one and the engrossed parchment at the National Archives in Washington are the only two ceremonial parchment versions of the manuscript. This was a collaborative project between Harvard, who was leading the project, the Declaration Project, West Sussex, who have the actual object, British Library, where we brought the manuscript for examination, Library of Congress, who did some processing, and University of York, who did some DNA analysis as well. And in terms of imaging, what we were interested here was looking at the date at the top right. So we can see there's something going on there, we're not quite sure what it was, so tried to enhance that. So the testing, the multispectral images were captured at the British Library, and then they were processed at Library of Congress. And what it revealed is a date underneath this erasure showing July 4, 178 or July 4, 179. So that critical number still eludes us. But it does tell us something else. It shows that it was written along this slight downward slant, so it's telling us that the clerk made two errors in the initial calligraphy for the date. So the first error being with regard to the date itself, so presumably used the year of production rather than the year in which the declaration was enacted, but also his error, or her error in failing to maintain this horizontal line. So useful in that term. And then nobody else was willing to actually go on television for this, so I was thrown again into the fire on CBS this morning. My ear was completely dilated, complete massive panic attack here when they were asking the Irish girl to talk about Magna Carta, which is British, and Declaration of Independence, which is American, and I have no history background. So that was exciting. Then Iron Gall ink, I just want to mention as well. So this is typically the ink that I spend most of my time imaging. So it's been used to write documents for nearly 2,000 years now, and its colour, it's what you're mostly familiar with looking at manuscripts, ranging from light grey to dark brown or black. If it's stable, it consists of iron pyrogalate, which is produced by combining iron sulfite to gallic acid. And if there's any excess in the iron sulfate or the gallic acid, then it will produce a pale ink, which is going to fade quickly over a period of centuries or even decades. And this fading can occur if the ink isn't mixed correctly, if it contains impurities, which is going to eventually render your text illegible. Which is where the chemical treatments, which I mentioned earlier, came in. So the aim of these chemical treatments was to try and rebalance those formulations and get that balance back to where the ink will become legible. And quite often it did work. So these people would come in, they'd see an important piece of text that was missing, get out their paintbrushes or whatever they were using, cover these areas with these different chemicals, and then sometimes the text would come back. Quite often they wouldn't even record what came up because they thought it had come back, and then a few days later it would turn into this horrendous looking mess on the side. The three primary reagents which have been identified are these three, and if you look at a lot of digitized collections now, in a lot of institutions you'll find these chemical stains throughout the digitized manuscripts. This particular one we did some imaging on is another example of the type of stain that's shown here, and it really shows us as well about the change in the concepts of textual and material integrity. So they're teaching us that the changing value of handwritten text in relation to editions in the 19th century, the hopes and the reckless enthusiasm of the first academic students and editors. So really, nowadays we would consider manuscript important just as a manuscript itself, not just what it's saying. Whereas it seems historically, when they were using these kind of treatments, they were just really only interested in what does it say, I just want to get a transcription of the text itself. And this one paper, Oliver Buck, where he describes the use of reagent in the Vercelli book, he says to modern eyes these stains which represent a gross violation of the manuscript's integrity is an important cultural artifact, using a chemical which may permanently damage the parchment and irreversibly destroy the text in exchange for a brief moment of better legibility must seem alien to our age of digital conservation and multispectral photography. Yes, it does. But luckily, multispectral imaging has proven to be quite useful for this type of damage. And in this particular example, We can see that there was actually an entire page of text here showing short Latin quotations and renderings from Jeremiah and Lamentations in Woolston's hand. This is a fragment of a previously unknown homily by Woolston. It shows legal notes relating to Alfred's first Latin letter, and it resembles a homily which was previously found. So this particular scholar was extremely excited about this. The other types of damage that happen to iron gall ink is corrosion. So this is blackening of the surrounding text, where the ink itself starts to eat into the parchment, so you can see you actually lose bits of the parchment itself, and obviously loss of legibility. This particular example here at the bottom is from the book of Sir Thomas More in 1728. This is again housed in glass housing, so it has 2 sheets of glass on either side. And we can see that there's a crystalline bloom observed on the surface which have been lined with this brown paper. And a lot of the ink has become corroded, making it pretty illegible in its current state. But luckily again, in the infrared this time, even though it's iron gall ink, for corrosion when we're trying to see through this damage, it's definitely a lot easier to see. In this example, you can see some areas where the text is being crossed out, and they've made different edits and additions which we haven't been able to read before. This type of loss of ink and eating into the parchment we can document as well using microscopy. So again, one of my roles is to aid in the condition assessment of items. So we would use microscopy to try and zoom in on these items. Quite often we might think that the ink is in a very good condition, but actually when you zoom in, a lot of the ink has been lost and it's just a stain of the original ink that you were looking at and being able to read. So it's trying to keep an eye on how much loss is happening over time by taking these types of images. Another major project that we have was looking at the St. Cuthbert Gospel, and this was using a CT examination. So we don't have CT scanner at the British Library, but they do have one at the Natural History Museum, which is where I did my PhD, so I knew everybody there, and they trusted me enough to explain what it is that we're going to do, and trust them that we weren't going to destroy their precious manuscript. This particular pocket gospel book, it's an early 8th century gospel, and it was placed in the coffin of St. Cuthbert. The coffin was opened in 1104 and the book was discovered inside, and that's basically why it is in such good condition, because it was in that coffin for so long and didn't get destroyed by other means. It is the oldest intact European book and one of the smallest Anglo-Saxon surviving manuscripts. It has 94 vellum folio and is a Latin copy of the Gospel of St. John, and it was acquired by the British Library for £9 million in 2012. So this binding itself is the most interesting feature of the item. It's the starting point for the history of bookbinding in Europe, and we were interested in this central panel. So the research question that they brought to me was, what is the material that's used as a foundation for this raised plant motif decoration in the front panel? And we can see underneath it has this Anglo-Saxon interlace panel, and this vine itself is representing several small leaves, and it has quite a significant Mediterranean influence. So the first thing that we did is start to do some microscopy, so similar to the high magnification images I showed of ink. We did that for St. Cuthbert. This is a Keon's digital microscope that we have. It has this motorized stage, so it's perfect for something that's small like St. Cuthbert. Obviously most of our collections wouldn't fit on this stage, but you can detach the lens and put it onto a copy stand and use it that way. And then some of the images that we get from microscopy were quite useful as well. So we can see the tool marks here were observed on this red goat skin binding, and what we were looking for is this kind of precision of the tooling marks to try and understand how it was that they would have applied this binding cover, what kind of tools they might have used, what kind of size blades they may have used as well. And we were also able to see that this yellow pigment was applied into the tooled trenches, and see where these slip marks were observed at many of the cross sections of the front. Again, these raised stems, which is what we were interested in, what's the material beneath it, really highlights how flat the goatskin leather is between these areas. The microscope itself is quite useful. If you're able to use a motorized stage, you're able to render these 3D images off. So if you just focus on the lowest point, focus on the highest point, and just tell it to focus on everything in between, it's able to output these kind of color height profiles. So it's the first time that we're able to get definitive measurements on quite a lot of these features. In order to look at the actual materials, that was the question, we tried to do some radiography. So obviously taking something out of the building is something that's really frowned upon. So we tried a few different things to not do that in the first place. We tried to do some standard radiography, and our idea was to compare it with a facsimile that had been made where we know what the materials were used, and then compare the two images to see were we right on what was in the facsimile and what wasn't. The results from that, got some information basically that it's definitely not gesso, and we can see the facsimiles on the left, St. Cuthbert is on the right, so these were quite useful to do. I did try and go down to our mailing room and ask them what kind of resolution their scanner had to try and put it through that, but it was terrible, so that's not going to happen. So we finally got permission to bring it to the Natural History Museum. This is the team, Dr. Claire Bray, Flavio Marzal, conservator, and myself, and Bill Gospel is inside. So we put it in this little phase box. We went phase box, imaged it standing up, and then also included a facsimile copy so that we could compare the two inside. And this is essentially what it would look like. So this is the original, and this is a phase box you're seeing outside it, and the facsimile on the other side. So what we got from this, the data cube then I had to process myself back at the British Library, and what we've done here is just taken cross sections of that data cube and just try and cut through the most obvious places which show the most information about that raised profile. And the bottom here, you can see this is a facsimile, so it's quite significantly a different material. We're still not quite sure what that material is, other than doing more invasive testing, but it gave us quite a bit of information about it's a cracked clay-like filler, so it's obviously something that's going to behave differently to the environment around it. And also we got good information on the cord-like structure that was used to show the squares around the initial finding. Other information it gave us was condition on the leather, so we were able to see these holes that were in the right board where beetles would have come out, so it's not just wood that we need to be concerned about, because quite often we are concerned with pest damage for wood, but not so much for leather, so it's something we have to think about now. And again, we can see this more clearly in other images. The CT scan also allowed us to make more definitive measurements that we had previously been able to do, so that was very useful for us. The other items that we get to look at are these oracle bones. So we did this project, which is a collaboration with the National Library of China. These oracle bones, we have about 50 of them. National Library of China has about 35,000 of them. So from their perspective, they're trying to figure out what best practice for how to present them, how to preserve them, how to store them, etc. So we're trying to do some experiments on our collections to try and figure out if we can help them to do that. The items here, they show the oldest Chinese script, and they also prove the existence of the Shang dynasty. And what they are based on is questions about crops, about the weather, battles, and ruling families. These questions were engraved onto either ox or antelope bone, sometimes tortoise shells as well. And then heat was applied to them, the bones would crack, and then the diviners from the Shang dynasty would produce these oracles, predictions for the future by interpreting the cracks and answer the questions. So initially, conservators, we examined the bones with a view to trying to digitize them using the usual methods. And visually looking at them, it suggested that the bones were brittle, vulnerable to movement and vibration, so quite concerning from that perspective. So we thought doing CT examination to try and get an understanding of the actual internal material would be quite useful. So one of the bones that we took over was this particular example. So the data that we collected there, again, I just made these videos for the presentation, but more interesting is some of the cross-section views that you can get. So this is imagining if you're looking through the bone right through the center. Any kind of change in colors, a change in density of the material. So you're getting a real understanding of that internal structure. So what we're looking at for is massive holes or massive cracks that we need to be really careful when handling these items. Obviously they're very vulnerable. Another bone that we did is this one here, and this is quite a large cross section at the top, so when we cut through this we're quite able to see a lot of the information through the bone. So this actually showed us that they're in better condition than we had thought, so we don't need to be quite as protective of them, but it's really the ultimate condition assessment for us in the future for any of these kind of items that we have. Obviously most of our items are 2D and not 3D, we get very excited when something isn't flat, so we don't have too much experience with that. But it's certainly a much more comprehensive way of understanding about the object and how we should care for it in the future. Another thing that I wanted to just briefly cover is enhancing digital images using colour space transformation. So quite often we give these presentations and the institution's like, well, we don't have a multispectral camera, we don't have someone dedicated to do this imaging, how are we supposed to do anything? But there are things that you can do to existing images. So if you just have a few images that you have already been captured, there is something that you can do. And that's using colour spaces. So you probably are familiar with colour spaces already. As humans, we pretty much define colour by its attributeness of brightness, hue, colourfulness, but then a computer might interpret that in a different way. So they might describe that colour using different amounts of red, green, blue, phosphor, emission, which is required to match the colour. Whereas a printer, they may produce specific colours in terms of reflectance and absorption of cyan, magenta, yellow, and black. So you might be familiar with changing the cartridges. Well, I'm always changing cyan and magenta cartridges when I want to have colour. And this is just a slide to kind of demonstrate that to you. So this is just a business card, which appears to be red. But in order for the printer to print this, in the original red, green, blue, it has to be transformed into this CMYK in order to print. And if you just zoom in on this, you'll see that the red really is just a combination of cyan, magenta, yellow, and black. So whereas RGB is additive, CMYK is subtractive. In a similar way, there are multiple different colour spaces that you can use. It's usually specified using coordinates or parameters, and this is a chromaticity diagram. Don't need to go through exact details of it, but it's just showing you that the parameters describe the position of the colour within the colour space being used. So they don't tell us what the colour is, that depends on what the particular colour space is. But they essentially determine the range of colours within which you can work. And this was applied to one of the projects that we also worked on. This is a Ming Dynasty paper money. It says on the top, circulatory treasury of the Great Ming Dynasty, and then this text in the centre is saying if anyone tries to counterfeit this, their heads will be chopped off. It's about A4 in size. Well, when the British Museum used to be part, or the British Library and the British Museum used to be one collection, but when we were separated into two different buildings, this particular collection was separated in two because they weren't sure if it should be with the money collection or should it be paper and stay with the library. So we both have the collection. We have 4 copies and the British Museum have 9. So we did a project to try and understand what type of mulberry papers were used in this. But we were able to use colour space on just a standard RGB image to give us further information. In this particular case, we can take our original RGB, and just by converting it, we can quite easily separate this seal. So you can see slight evidence of this red seal in the centre, but it comes out completely legible in the right hand when you're able to separate it. There's multiple colour spaces that you can use. The 5 major models subdivided into others. So if you are familiar with using, I use ImageJ, there's lots of different things that you can use. And there's also a website called Retro Reveal, which basically runs on the ImageJ engine, but it enables you to just upload your image and pump it, and it will give you all the different colour spaces. And hopefully you will go on to figure out what it exactly is you're trying to read. And in conclusion, specialist imaging, certainly at the British Library, it's improved accessibility, conservation, and our preservation practices. Some of the primary challenges which were posed by fire damaged, indistinct chemically damaged materials are certainly being overcome by multispectral. CT scanning enables our scholars their research questions, as well as to inform our conservation about housing decisions that we need to make in the future. Data processing of existing images can reveal new information, so certainly it's very useful for institutions that don't have the kind of resources available to do this kind of tech and to still be finding new things about their collections. And also just to remember that the human desire for conclusions is stronger than the desire to observe. So we've kind of found over the years that when it comes to interpretation, people, they come in sometimes wanting to read a particular thing in their head, and it can get quite carried away with that. So it's really important that scientists and scholars work in collaboration. These discussions are had about what definitely is, what isn't there, and just to consider all of the options around what might be imaged. And sorry, I had to talk so fast for that, but hopefully give you a brief overview of the type of imaging that we do at the library, and I'll be happy to answer any questions.
We have time for questions. Helen.
Thank you for a wonderful talk. That was great. I really enjoyed that. I have a question about how you select which manuscripts are going to get multispectrally imaged. Some of them were clearly damaged, some of them were clearly palimpsested. but the St. Petrarch Gospels that you showed that had the empty roundels.
Yes.
Did they suspect that something was there? Because that manuscript did not look damaged at all, so.
Yes, so for any of the major treasure items,
Yeah.
so like the Magna Cartas, anything that's anniversaries, quite often the library is centered around an anniversary of something, and we're going to have an exhibition about it in such and such a year. So we'll choose any manuscripts that will be related to that, so that we have all the up-to-date information on it. So we do as much scientific research on those items as we can. So that's kind of scheduled in overall. And anything that's erased, yeah, you're right, it's quite obvious if something's damaged or erased, someone will flag it up and we'll image it straight away. The Bodleian Gospels, which is the St. Petrarch manuscript, is the same thing. Certainly it's not damaged, it is online, digitized, and there are some indications of names on it, but certainly not to the extent that we found. But quite often in the catalogues, somebody might have noted down that in the past it has been said that these have also contained the names of, so it can quite often be hand-me-down information from the past that might inspire further information on.
Yeah.
One of the objects you showed was the brain.
Yes.
Have you tried to attack that? Have you tried 3D imaging and taking slices, or?
No, we haven't done anything to do with that yet. I know there's quite a lot of work being done on parchment, like Pompeii type material that's being taken over by Mount Vesuvius, and they're trying to unwrap it digitally. I think St. Mary's are doing quite a bit on that, so I think it might be useful for that to try and, certainly if the iron gall ink is used, iron is quite easy to detect in something like a CT scan, so you can pick that out quite easily. I think the post-processing for those kind of projects, certainly from my perspective, is overwhelming challenge. It would be something that we'd have to do as a bigger contribution. So I think the processing on that would be certainly more time intensive than the actual capture.
So is it like rigid, like a brick? Or?
Yeah, it's somewhat flexible on the edges. The center core is quite rigid. We don't really
I'm expecting Gregory to.
Well, I think the Brent Seals would be really interested in. If you
Yes.
want, we can talk about it. I'm sure he'd leap on that, and he and his team could do all the processing. Or we could,
Yeah, because
we also have the.
We had a similar thing, well, maybe not similar, but similar problem at Sharp.
Yeah.
This brick of parchment, and Brent Seals did, and you could see characters. I mean,
Yeah.
you know, he hasn't yet been able to.
We have the code though. He gave us that code. We could work with it, but he's probably made some refinements on it since then. But that would be an easy one. He's looking for something easier than Herculaneum, because the papyrus is so damn thin. You have to trace the edges, but on parchment, and because it's iron gall.
That's a good point.
It would make it would be a big win for him. So he'd jump on that, I think.
And the brick that you guys worked on in Shark was I mean, it was a brick.
Much harder.
It was
Yeah.
burned. It was damaged
But
in the bottom.
you can see
So it's all
characters
convoluted.
plain as day.
You can, but on this, it's
You can't
really
unravel
easy.
them.
It'll be really easy to trace
Yeah.
the
I
parchment
agree.
lines because they're all regular and
Yeah.
relatively straight.
Dave?
Have you done any, or has anybody proposed to do, using this system to do temporal monitoring of the objects?
That's
Like
it.
change detection, go back and image that very important Magna Carta every year or something, and try to identify weak spots or changes or something like that?
Yeah, it's something that I guess when we purchased the equipment the first time, we thought maybe this is something we would do as part of condition assessment. But I think as the years have gone by, it's trying to get that environment to be exactly the same, and the calibration, the setup, and everything to be ideal. It isn't something that we've certainly attempted to do at this point, but it is something that definitely we should be doing on significant items like that.
Have you talked to Ken about it?
Yes, Ken loves talking about that.
Yeah. But I say,
That-
when you have
Ken
talked,
has
can I
talked to me
actually,
about
has
that,
Ken
yes.
talked to you about it?
Yeah,
So-
Ken Boydston, the guy who runs Megavision, is a close associate of all of ours, and that's one of his big things right now, is using the system to characterize progression and degradation.
So right now your goal is to recover the text. Has there been much effort in recovering the appearance, maybe based on assumptions about what materials you're likely imaging?
In terms of conservation.
Yeah, because you're imaging outside the human range, really, right, in infrared. So
Yeah.
any estimate, are you able to estimate what it might have appeared like at the time in the human visible range?
Yeah, I mean, we can certainly create color images based on the monochrome recovered text that we have. We wouldn't do anything to the object to make it return to look like as it is.
Right. So have you like tried to image any art or anything that's not, right now you're just focused on recovering the text. Have you ever created artificial approximations of something that was colorful?
Yeah, one item that I have looked at is actually for Trinity College Dublin. So they have a lot of, again, burnt material like this, and quite often the lines of text are quite skewed, so it is legible. But he was asking, could you straighten it up so that they could compare it to a folio that was in Cambridge. I was like, well, you can already read it, it doesn't need to be straight. But anyway, we ended up being able to do that. So you can apply different algorithms to straighten the text. So he had a better comparison between two existing texts. So it is something that if someone does really ask and has a reason to do it, we would do that. But otherwise, we kind of steer away from that because it's basically just photoshopping the item. It's not really how it looks currently.
But she's chatting with Jim tomorrow about visual rendering of some of the objects.
Okay.
You were showing some of the texts that were papyrus and not just paper. What's your method of keeping that in focus as you image the document?
The papyrus in the glass housing.
No, it was a book of parchment that was.
Oh, that's parchment inlaid in paper.
Yeah.
Yeah, so that is certainly very tricky. Really, the only way we can do is which bit is the most flat, and just do that. If it's extremely significant, then we could do different size, but it's not something that we'd montage together at the end. Not something I might be able to do at this point.
Do you use Ken's parallel laser bar? Or
No, we don't have laser bars. He keeps saying get the laser bars here.
I don't have to go.
We didn't use it in Vienna last week either.
No. If you want, I'll let you ask Catastrophe. We're not using it.
Yes, please.
Sure.
Thank you.
Any other questions? Okay, well, let's take a